Lecture 7, Part 1. Continuous probability distributions. A continuous random variable is a random variable that can assume any value within some interval or intervals. For continuous random variable, we may wish to know the percent of observations that occur within a certain range. Let's have a look at this picture here. This represents a slightly positively skewed distribution. And let's say we were interested in finding the area between value A and value B. We'd be finding the area of that shaded region. Now, if you think back throughout your education, what you'll understand is you haven't really learned how to find, or there's not a clear formula on how to find the area of a shape that is slightly circular. Right? We know how to find the shape of triangles, how to find the shape of rectangles, etc. But in order to find the shape of this distribution, you'd have to be using calculus. Now, for our class purposes, we're going to be only using a specific type of distribution, so we do not have to rely on calculus. In classes, let's say you take later on, where potentially you may need to do a little bit more work in terms of understanding calculus and understanding the distribution, then you may need to look at calculus in order to find the area of this distribution. So in this case, we're going to be looking at two types of continuous probability distribution. We're going to start with the uniform, then we're going to do the normal distribution. The normal distribution is where we're going to spend most of our time, as we'll start it in this chapter and then we will use it in pretty much every chapter to come. So let's start with the uniform distribution. The uniform distribution is used to describe continuous random variables that appear to have equally likely outcomes over the range of their possible values. The distribution is rectangular in shape and is defined by the minimum and maximum value. One thing I want to just define right up front before you even get started is the area that you're looking for in a uniform distribution is like the area of a rectangle. So in order to find the area, you just simply do base times height. Keep that in mind. This is going to be the key to the uniform distribution. A few key formulas for the uniform distribution. First is how we find the mean. And the mean is basically A plus B, where A is the minimum value in the distribution, B is the maximum divided by 2. Here, basically in this distribution, since it's perfectly symmetrical, the mean is also equal to the median. The standard deviation is found by sigma, which is equal to the square root of b minus a squared divided by 12. The uniform distribution itself, we can state it as the probability of a value x is found by 1 divided by b minus a. So it's like saying 1 divided by the maximum minus the minimum, or the range of the distribution. Let's work through this with an example. Here's our example. University provides bus service to students while they are on campus. A bus arrives at the North Main Street College Drive stop every 30 minutes between 6 a.m. and 11 p.m. Students arrive at the bus stop at random times. The time a student waits is uniformly distributed between 0 and 30 minutes. I want you to visualize this real quickly. Let's think about this. You get to the bus stop, the bus is there, and you jump in. You waited 0 minutes, okay? You get to a bus stop, you wait 30 minutes, and you jump in, you waited 30 minutes. Basically what we're saying is that the exact maximum amount of time you could ever wait is 30 minutes, no more than that. And the minimum time that you'd wait for your bus is 0 minutes, no less than that. Let's answer a few questions. First, in our example, we're going to start by drawing a graph of the distribution. This is very important. Everything we do from this point onward, we will start by drawing a picture of the distribution. Second, we're going to show that the area of the distribution is 1 or 100%. Third, we'll ask the question, how long will a student typically wait for the bus? And then we'll look at the standard deviation. Then we'll ask, what is the probability a student will wait at least 25 minutes? And what is the probability a student will wait between 10 and 20 minutes? So in this example, we said the probability, right, the initial starting point of this was the student may wait 0 minutes or the student may wait 30 minutes. Now recall that the probability of any x value, any given outcome in this distribution, is going to be 1 over the max minus min, in this case 30 minus 0, which in this case would be 1 over 30, or 0.0333. Now, what does that mean? It's basically saying when you get to the bus stop, the probability that you wait exactly 10 minutes is 1 over 30. The probability that you wait exactly 20 minutes is 1 over 30. The probability that you wait, say, 25 minutes is 1 over 30. The probability you wait 30 minutes is also 1 over 30. That's where the word uniform comes from in this specific distribution. Now let's prove that area is probability. To prove this, it's very simple. We take our drawing where we've drawn an x-axis where we have the length of time that we wait. We've labeled the maximum as 30 minutes. Our y-axis is going to be labeled with the probability of x. As you remember before, when we did frequency distributions, this was f of x, which is almost exactly the same as the probability of x. And in this case, we know that the probability of any given outcome in this distribution is basically 1 over 30. So that means if we were to find the area of this distribution, we would simply do base, which is 30, times the height, which is here, right, 1 over 30, which means our distribution is equal to the total of 1. This is like saying, what is the probability that a student gets to the bus stop and waits between 0 and 30 minutes? We would say it's equal to 100%. The mean and standard deviation. So the mean is simply basically what we call the typical. So whenever you see the word typical or expected, etc., this is the mean of the distribution. In this case, we take the minimum plus the maximum divided by 2, clearly the midpoint, and we find that the average is a student waits 15 minutes. The standard deviation is simply the square root of b minus a squared divided by 12, which is 8.66. So let's answer that first question. What is the probability a student will wait at least 25 minutes? So at least basically means 25 or more. So we're finding the area of the shaded region here, which is the area between 25 and 30, this orange region. So first, what's the base? Well, the base is 5, 30 minus 5, which is our 25 value, times the height, which is 1 over 30, or 0.0333, and the probability that a student waits at least 25 minutes is going to be 16.67%. Now, what is the probability a student will wait between 10 minutes and 20 minutes? Well, that probability is found again by starting to draw your picture. Your picture starts at 0, goes all the way to 30, and in this case, we're looking for the area between 10 and 20. What's the base? The base is 20 minus 10, or 10, times the height, which is 0.0333, and basically that gives us an area of 0.3333, or 33.33%. So the probability that a student waits between 10 minutes and 20 minutes is 33.33%. Here's a second example. And this one you guys will work through and we'll review it in class. So the question says, customer service calls to Acme Inc. take between 150 and 12 minutes. What is the expected time to resolve a call? So here you will find the mean time to resolve the call. We'll find what percentage of calls take more than 30 minutes. And this is a tricky one. What are the endpoints of the middle 50% of calls? The first thing you want to do is convert either the seconds into minutes or the minutes into seconds. I'll let you guys make that distinction. So work through this problem and we'll solve it together in class.